Welcome to Michael Plummer's Milestone 4 presentation, Open Architecture. I'm Carlo Parente, and I'll be acting as the program rep. As part of the committee, we have two guests joining us today. We have Tanya Bortolotto, who is the founder and president of the Toronto-based design firm Bortolotto Design. Tanya is an architect and interior designer and a fellow of the Royal Architectural Institute of Canada. Tanya currently serves as the director of Inscape Corp and was an inaugural member of Waterfront Toronto Design Panel Review. We also have Talbot Sweetapple joining us, who is a partner with Brian McKay-Lyons at McKay-Lyons Sweetapple Architects. Talbot is also a fellow of the Royal Architectural Institute of Canada and is also an assistant professor at Dalhousie University. As part of his committee, we have Paul Florke, who is Michael's supervisor, Jason Ramelson, who is the second reader, and we have Marco Polo as the Associate Chair of Graduate Studies joining us as well. Marco, as per your previous milestones, you'll have 20 minutes. I believe you have a video that will be played, and then we'll have about 30 minutes for clarifications and questions and comments from the committee. Okay, I guess we'll start the video now.
Hello and welcome to my Milestone 4 presentation. Firstly, I would like to publicly acknowledge and thank the individuals who are instrumental in the development of this thesis. Throughout this past year, I have received a great deal of support and guidance for which I am truly thankful for. First, I would like to thank my supervisor, Dr. Paul Florke, for his continued dedication to the research, design, and practice of New Wood open architecture. This thesis would not have been possible without his expertise and guidance. He patiently led me through challenging concepts and pushed me to develop my position among them. I would also like to thank my other thesis committee members, my second reader, Jason Ramelson, for providing invaluable technical critique and knowledge, which helped me take theoretical concepts and apply them to design and construction. My program representative, Carlo Parente, for his valuable critique with respect to both architectural theory and practice. Finally, I would like to thank my family for their endless support throughout this past year. They provided me with the tools and resources to explore my ideas without question or concern. This thesis would not have been possible without their help, and for that I am truly grateful. This presentation is structured around 4 main sections that highlight the development of this thesis over the past year. The first part will focus on the scholarly research that underpins the theoretical arguments made with respect to open architecture, participation, and technology. Literature and case study reviews present the existing body of work and how the concepts they explore tangentially address the scope of this thesis. This research directly informed a design-build project that applied the major research findings. The design-build project is an open-source, modular construction system that allows dwellers to participate in the design, assembly, and maintenance of their dwellings. The system was deployed on a specific site in Haliburton, Ontario, in order to further investigate its material and spatial qualities. The design-build project was a valuable opportunity to test the aspects of this thesis that involved the physical sourcing, fabrication, and assembly of building materials. Finally, the implications of the system and other important findings will be discussed to conclude the presentation. The COVID-19 global pandemic demonstrates how volatile everyday life can be. Social distancing, quarantine, and virtual communication are all examples of the sudden changes to our daily routines that were prompted by the pressing public health crisis. These habits and rituals are deeply rooted in our interactions with one another and the built environment. The pandemic has significantly altered or cut off these interactions, disrupting the comforting predictability and consistency of everyday life. For example, the program and organization of the home is being pushed to its limits. As schools, workplaces, and public buildings close, the home has rapidly inherited these unanticipated functions. Social distancing and quarantine have forced people to stay inside for longer and use their homes in unprecedented ways. The personal dwelling environment has morphed to simultaneously become a school, a store, a daycare, an office, and other functions of the built environment. COVID-19 provides a unique opportunity to critically evaluate the relationship we have with the built environment and critically examine how responsive it is to dwelling needs as they inevitably change. There is a dynamic relationship between the built environment and those who dwell within it. Dwellers both influence and are influenced by the everyday environment they inhabit. For architecture to make meaningful contributions to these environments, it must privilege the input and energy of the dweller. This calls for an architecture that is open to participation throughout its planning, design, and building process, an open architecture. Using emerging open source and fabrication technology, open architecture establishes the natural relationship between dweller and dwelling. The dweller and their unique needs and insights is included within the architectural process. This results in a personalized dwelling environment that remains flexible, resilient, and truly sustainable. The following scholarly research provides valuable context for which to position this thesis by answering the primary research questions: what is open architecture, what is participation in architecture, and what role does technology play in open architecture? The following literary and case study references were analyzed to develop a definition and evaluation criteria for open architecture. Oscar Henson's theory on open form was investigated along with a case study of his summer house in Szumin, Poland. The self-built project thoroughly involved the Hensons in essentially every stage of the project. This included the initial design process, the pouring of the concrete wall, and the following years of ongoing expansion and experimentation. Technology played an important role in allowing the open form to adapt as dweller needs changed. The timber-framed pitched roof has no interior load-bearing walls, allowing for endless configuration and reconfiguration of interior spaces. However, the project did make use of building technologies that are more resistive to future change. The reinforced concrete wall is difficult to modify once fully cured. New openings would require specialized concrete cutting machinery and expertise. Something as simple as attaching components to the wall requires special anchors and adhesives. Next, John Habraken's open building concept was explored and analyzed. The open building philosophy deploys Habraken's levels in the built environment to denote physical hierarchies and domains of intervention. The alternative strategy he proposed, called supports, separates the building's structure and services from the infilled dwelling units. Elemental's Villa Verde was studied as an example of open building theory. The award-winning project strategically deployed innovative participation techniques to provide affordable housing units by providing the support structure and initial dwelling. Dwellers were able to move in immediately and expand later as necessary. The infill is limited to the defined boundary of the support structure. Dwellers only participate in the infilling process. The support system is constructed uniformly and efficiently to save cost. Finally, a contemporary application of the term open comes from Carlo Ratti's book titled Open Source Architecture. It outlines a new vision of how architecture must adapt to the realities of the contemporary world by adopting open frameworks for sharing architectural ideas and information. Ratti argued that architecture should adopt a network, collaborative, and inclusive model similar to open source software and network development like Linux and Wikipedia. A case study example is Studio 00's WikiHouse project. This project redefined the design, manufacturing, and assembly of buildings as a result of the Third Industrial Revolution. Dwellers meaningfully participated in the design and assembly process. The system was flexible and adaptive to reflect the unique architectural characteristics derived from the dweller, the site, and the budget. WikiHouse took advantage of digital design and fabrication technologies to create a structural plywood system that can be downloaded, customized, and manufactured via CNC router. The digital files are open source, free, and protected under the Creative Commons licensing structure. Oscar Henson's theory on open form, John Habraken's open building movement, and Carlo Ratti's contemporary text on open source architecture all contributed to defining a profound shift in architectural design, fabrication, and construction by including the dweller in the dwelling process. Case study examples like the Henson House, Villa Verde, and WikiHouse all represent applications of these ideas in physical, material, and spatial form. This scholarly context defined the theoretical use and architectural application of the term open architecture. Participation in architecture is another essential aspect of this thesis that demanded scholarly context and research. Active and passive participation define the quality and breadth of involvement the dweller is afforded. Active participants play a pivotal role in the design, construction, and maintenance of their dwellings. They hold responsibility over its provision and develop lasting relationships with each other and the built environment they inhabit. It also fosters critical awareness of architecture's role in climate change, resource extraction, and energy consumption. Walter Siegel emerged as a seminal reference for deeply involving the dweller in the entire dwelling process through self-building. Walter's Way, the self-built community in London's Lewisham neighbourhood, revealed the positive community building result of involving the user in the architectural process. Walter Siegel developed a modular construction system of timber framing and sheathing that allowed dwellers to participate and modify their own homes. Here, the construction method is made accessible to the amateur builder in order to allow them the agency to shape their own place of habitation. The role of technology in architecture was then explored and contextualized. The above references all demonstrate the complex relationship between participation and technology. Technology is a means of deeply involving the dweller in the dwelling process. Hard and soft technology define the extents of how technology either promotes or inhibits participation in the architectural process. This thesis aims to push the limits of participation in architecture using emerging open source and fabrication technology to significantly involve the dweller in the design, fabrication, and building process. An example of architects making use of emerging technology as a means of increasing dweller participation in the dwelling process is the U-Build system developed by Studio Bark. This project is a modular construction system that allows dwellers to self-build. The aim is to make architecture accessible to more people by reducing cost and involving dwellers in the process. U-Build has an interactive design tool built into their website that allows users to customize the U-Build system to suit their specific needs. The previously mentioned references defined essential research terminology such as open, technology, and participation, and each contributed to defining and evaluating open architecture. By answering the final research question, why open wood architecture, this section will argue that wood is uniquely suited for designing and building open architecture. New Wood Open Architecture explores the application of open architecture principles using primarily wood assemblies, joints, and finishes. Wood becomes the vessel by which participation and adaptation are integrated into the tectonics and materiality of the resulting architecture. New Wood Open Architecture meaningfully involves the dweller in the design, building, and maintenance of their dwellings. Through physical engagement with wood building components and assemblies, the dweller will form a more sincere and lasting relationship with their dwelling environment. This in turn leads to a critical understanding of where wood components are sourced, how they are manufactured, and the impact of this process on forest ecology and sustainability. Other material-specific topics were investigated to argue that wood was an ideal material for open architecture. Design for disassembly, workability, prefabrication, modularity, standardization, and maintenance emerged as important concepts. They highlight how the unique material properties of wood makes it an ideal material suited for use in detailing and building open architecture in Canada. The Haliburton Forest was visited and investigated in order to better understand how wood materials are sourced and sustainably managed. The Haliburton Forest is the largest sustainable forest in Canada and manages a 100-acre parcel of forest in Haliburton, Ontario. An on-site lumber mill processes the raw material sourced from within the forest, and the lumber is then sold to the public. This site visit contextualized the use of wood materials in architecture by better understanding the entire process from the way in which forest plots are sustainably managed to the milling of harvested trees into usable building materials. The above-mentioned research was then synthesized into a design-build project that aimed to apply the research findings to a specific site in Haliburton, Ontario. The New Wood Open Architecture Library is a parametricized modular construction system that allows dwellers to participate in the design, fabrication, and building process. Rhino V6 and Grasshopper were used to digitally represent the modular components of the library. The components are parametricized to allow the dwellers to more easily engage in the design process. Parameters like wall height, opening size, and location are flexible to a specific dweller's context and needs. The parametric massing model allows scale, location, and style to be determined. When massing is determined, the required floor, wall, and roof components are applied to the designed massing. Massing is also intentionally designed to facilitate change over time. This drawing demonstrates this process over the course of 20 years. As dwelling needs change, the construction system is responsive and expands to facilitate additional uses. This expansion can occur in either the X, Y, or Z direction. The components from the previous dwelling are all reused in the construction of the next iteration. Exterior deck space is used in every iteration as an area for simple future expansion, as footings and foundations are already in place. The components can then be converted to construction drawings and prefabricated off-site. After fabrication, the components are efficiently stacked onto a standard truck bed and delivered to the site for assembly. The assembly process demands participation as dwellers assemble the pieces they designed using the digital design tool. Component size and weight were considered to ensure safe assembly by a small team of amateur builders. Participation at this point in the dwelling process allows the dweller to physically engage with the materials and develop an understanding of where they were sourced and their environmental impact. This drawing shows how the system can be used to meet a wide range of housing needs that might exist in a given neighborhood. The 2-foot module is small enough to allow for fine-grained personal modification of the built environment, such as front porch renovations or deck building. While these small projects do not provide housing on their own, they are opportunities for dwellers to imprint their personal identity on the built environment they inhabit. The module is also small enough to allow for expansion of existing dwellings to add additional space and functionality. In densely populated urban areas like Toronto, Ontario, the system can also be used to add additional housing supply through new builds. This can occur at various scales ranging from laneway suites to multifamily residential. Whether the system is used to replace a deteriorating front porch or to develop a multifamily residential building, the resulting architecture remains resilient and responsive to both the community and dwelling needs as they change over time. This also demonstrates how the system is responsive to housing needs that vary depending on geographic location. This shows how the system responds to housing needs in urban areas where density is higher. In light of COVID-19 and related lockdown measures, working from home has become normalized and acceptable. This reduces the demand for housing in urban areas as more employers allow employees to continue to work from home. In turn, housing demand in more rural areas increases. COVID-19 and the sudden changes to housing demand based on geographic location is a perfect example of why flexibility and resiliency are essential to the sustainability of a construction system and the resiliency of the built environment at large. The proposed site is located in Haliburton, Ontario, approximately 2.5 hours northeast of Toronto. It currently sits vacant on Peninsula Road among neighboring cottages and homes. The north end of the site is forested and divided by an easement for hydro lines above. The south end of the site is less densely forested and open to the lake channel connecting Grash and Kishagawiggamog Lake. The site is part of the organized township of Dysart et al. And is subject to its zoning bylaws. The proposed location of the design-build project is based on these setbacks that protect the natural shoreline from ecosystem damage. The location of the Phase 1 construction must also account for future expansion without necessitating the removal of the mature trees on site. The 12 by 12 foot module shown represents the open support structure by which the intermediate components, such as windows, doors, and solid panels, can be customized to suit the needs and preferences of the dweller. The supports are made up of 6 floor components, 4 corner assemblies, and 4 wood lintels that span each opening. This allows for a high degree of flexibility within each of the 4 sides. This flexibility allows for a variety of infill options, such as exterior walls with windows, doors, or solid, or one large opening to gain access to adjoining 12 by 12 foot module. The lintels are adequately sized to accommodate a floor above, providing the opportunity to expand the system in the Z direction without conflicting with the infill below. The detailing between components of the new wood open architecture library must allow for the flexibility and disassembly of components while also providing the necessary structural, insulation, and waterproofing performance. A one-to-one model of the wall at floor detail demonstrates these constraints in a variety of areas. The first area is the removable baseboard that provides access to attach the floor and wall components. During assembly, the baseboard is removed to screw the components together. This space also serves as a service channel to run electrical between wall components. The alignment joint between the base plate of the wall and the floor component serves to align the two components quickly and reliably. The components are assembled before the exterior cladding is installed, and then a French cleat anchor is used to hang the prefabricated cladding screen from the wall components. This allows the cladding to be removed in one piece for maintenance. The cladding panels can be removed, cleaned, sanded, and refinished much more safely and regularly. This prolongs the life of the exposed wood elements and allows the dweller to further participate in the dwelling process throughout the building's life. The design build project was a valuable opportunity to test the aspects of this thesis that involve the physical sourcing, fabrication, and assembly of wood building materials. The initially assumed ubiquity of standardized lumber in the consumer marketplace was not exactly correct. In reality, the market for lumber fluctuates based on seasonal supply and demand. This was exacerbated by COVID-19 and the sudden increase in demand for home improvement products and materials. During the fabrication process, the simplicity and modularity of the system provided a significant advantage over a more conventional stick framing process. The majority of wood members were not cut to length prior to assembly, as the modular system is based on standard lumber dimensions. This greatly increased the efficiency of fabrication and basically eliminated any material waste. The joint between components could be investigated further to try to improve the energy performance and airtightness of the building envelope. While the butt joint between components provided significant advantages with respect to simplicity and ease of disassembly, it did introduce obvious challenges with respect to moisture and airtightness of the envelope. This system prioritizes the ongoing flexibility and changeability of the building's form, structure, and spatial organization, but this came at the expense of limiting the seams between interior and exterior. By using flax wool or wood fiber insulation between components and taping the seams, a balance could be struck between the system's flexibility and its thermal performance. The assembly process was an opportunity to verify the earlier assumptions about the size and weight of each module. This was undoubtedly one of the biggest assumptions made throughout the design process, as this parameter is difficult to verify using digital models and drawings. Despite this, the 12-foot floor components were light enough so that 2 people could safely move them a reasonable distance. The wall components are lightweight and easily positioned on the floor components below. With the addition of more components, the structure got increasingly more rigid and resistant to shear and lateral forces. This thesis argued for the value of participation and sincere involvement in the process by which a dwelling is designed, assembled, and appropriated to suit the unique needs of those who dwell within it. The New Wood Open Architecture Library uses emerging technology as a means of accomplishing this aim, and this design build project was an invaluable research exploration that tested the system at full scale. It provided me with the opportunity to physically participate and explore the meaning and value by which that participation brings to the resulting architecture. Thank you for taking the time to review my Milestone 4 presentation. I look forward to your questions and feedback.
Thank you, Michael. Now I'm going to open the floor up for questions of clarification from our guests. Tanya and Talbot, if you have any questions of clarification.
I have one. When you say milestone 4, can you describe that? Is that the final, or is it
This is the final.
okay.
So I have a question in regards to the dweller and participatory, what their involvement would be, like is in terms of participating in the design. Can you just elaborate a little bit on that?
Sure, yeah, so that would come in sort of the form of similar to what the UBuild system did. I showed it earlier in the presentation, but they basically have an interactive design tool that is an extension of their website. And that basically is, it's a proprietary software that works with their unique construction system. And it essentially takes the client through the kind of preliminary planning phase all the way into the construction document phase. So as far as, like people participating in the design process, I think a lot of that is happening, at least with the UBuild system. And what I was sort of envisioning is it's happening kind of on the client's time, on the dweller's time. And, the role of the architect then is sort of facilitating and acting as the sort of expert with this system. And the only difference really is that, it's online, it's accessible, and it's open source, so it's available for free. It's not about kind of creating the system and making it proprietary. It's really about making it accessible and making it, it's making the design process a lot more accessible than I think the way it kind of functions now if you want to hire an architect to design your home.
Talbot, any questions of clarification, or we can open it up to comments as well?
Oh, I think I got it. Go ahead.
And I can share the PDFs if anyone wants to reference drawings or anything. I just don't know if it'll make our screens smaller, but I don't mind sharing at all. Just mention it to me.
Mm-hmm.
Okay.
Comments?
Should
Yeah.
anyone start?
Go. Yeah, go ahead.
Okay. Well, your introduction was to the background and the introduction of the project and your research. It was very clear and concise, and the timeline told a story, and I thought it was interesting. It was compelling. Lots of ideas, lots of thoughts, and it seems like you've spent a lot of time on this project. And it covers many topics, like from design to design build and flexibility and digital design and technology and construction detailing. And you actually implemented it yourself, testing it, which I thought was quite impressive. I guess on the one hand, when I think of participating in design, for me, I kind of think of, like, just within your project, I think, or thesis, I think of sort of custom design versus mass production and component pieces. And I feel like there's a little bit of a conflict or contradiction between being super flexible and, being able to participate in the design where you can get whatever you want or do whatever you want and then build it. So that's interesting as well, that sort of tension between customization or personalization versus these component pieces and having only a few choices or several choices, but you can't just open up the gates in terms of whatever you want. So I thought that was interesting, and just in that the lines are blurred in that regard. I think there was another, I guess the question is, at what point is the participatory process difficult using component pieces to create something? It's just a question, I guess.
Right. Should I answer? I mean, it's not,
Sure.
I don't know if you're looking for an answer, but yeah, I think, no, it's definitely a good point. And it's something that, because I could have just made it so it's sort of like the fact that you're limiting it to a 2-foot module means you're restricting people who wanted maybe a 3-foot module, right? So the idea, I think, with finding a balance between these two ideas that you're talking about is figuring out where within a standardized frame, let's say, you can actually add a lot of opportunity for customization. So that was happening, I think, at various scales. Like the part that I actually built is kind of essential. Like that's the structure. You can't really mess around with that too much. But then within each of those massive openings, or those 8-foot openings, there's a high degree of flexibility as far as, you know, windows, doors, door heights, or window heights, and all these things. But that's kind of happening within the defined, you know, framework that the system kind of requires in order for it to, you know, be structurally sound. So I agree, it's a tension for sure.
Talbot, do you have any?
I'm on a similar vein here. You have a lot of topics in your thesis, and it seems like you try to solve a lot of issues. And typically when I see theses, I see them a little more focused and a little more, either it's a thesis about wood, or it's a thesis about participation, or it's a thesis about dwelling and, you know, et cetera. So you're trying to do it all. And I think that's, you're mocking actually reality, you know, in a way that you, as an architect, you got to think about all those things. There are always a daily thesis going on about how you get stuff to site. How do you build stuff? What's the modular? Does it make sense to build off site and bring to site? You know, all those things are engaged. And then how much user interface and user participation do you really want? And how much do they really want to give? You know, so you got all these topics here. And I was hoping, and I was reading your thesis a week ago, and I was hoping that I'd see a little more of an indication of an example. Like your 2-foot module is one thing. And if you told me that the reason it's a 2-foot module is because 2 people can carry it and you can build it all off site, and you're not that far away from just taking 2 pieces of 2x4 and bringing them to the site and putting the nails on site. You know what I mean? Putting it on there. You know what I mean? So you're at the beginning of a very, it's going to take the rest of your life if you're still interested in this to really solidify a viewpoint on this. But you know, I did like the sequence of where your panels were being built on top of each other, and then you use that as a table to build the next one. And it's like almost like a template, but not quite. You know, so this is where I'm sort of brushing around a bunch of different things, probably because I'm trying to figure out where you would like us to discuss your project. And because the participation level I didn't see there, and I know you said it a lot, and your beginning was kind of good in that way, but I didn't see the participation aspect of this at the end. You say it's flexible and they can do whatever they want, but it would be really interesting maybe to do a case study on how the participation in sort of led to, or how they participate really, because I was quite confused with how they can participate. Do they get on a program and just start moving these 2-foot modules, or they, you know, is there rules that they follow? Is there a series of questions? Like we did this years ago where, you know, we had a module happening. It was called the LaHave House, and it was based on the grammar of our work. And, you know, the first question they ask you is, where's the sun? You know, so, okay, that tells you where you might put a door. Where's the view? You know, how many bedrooms? How many, what size kitchen? You know, they ask you those sort of questions of dwelling. Is it that kind of thing where it's a survey, or do you actually asking people to move walls around with their mouse? So that whole participation interface, I was a little bit, if you could tell us a little bit more about that, maybe, so I don't keep talking here, just to bring some clarification to that, maybe.
Yeah, sure. So yeah, I think it's a bit of both, because a lot of it is, well, a lot of the parameters that I discussed in like that are embedded within the parametric model are kind of hard facts that you could easily just get, you know, filled out on a form, and those are then transferred, you know, inputted as parameters into the model. But I really tried to sort of think about how, you don't really want to just bombard someone who has no idea about housing or construction, bombard them with all of the data that's embedded within the parametric model, because it's just an overload of data that you don't need early on in the project. So if you can sort of think about it as like, I think this is how we learn about it in like Design Studio 1 in undergrad, where you're starting with massing and you're sort of like thinking about where the sun is and where the exposure is and where you want privacy. And this has nothing to do with construction. So all of those parameters are basically turned off. And then as you require more information, as you move into design development and eventually construction drawings, those embedded parameters become more important. But I think early on, it's important to restrict those so that, you know, you're really discussing what's important at a given point. And I think it definitely needs some sort of, you know, interactive modeling component, because I think a lot of it is visual, where, you know, reading even a 2D plan, we're all very familiar with that very specific view, but as someone who has no experience with that, even a plan view could potentially be confusing. So I think some sort of 3D interactive modeling, you know, like software, whether it's a plugin for an existing modeling software or if it's an online tool, something that's just accessible. That's why I kind of like the online tool, because then you can just send a link to anyone and it's really easy to share.
That's good. It's good. That helps a lot. I'd love to see everything you just said graphically. You know what I mean? Like, what is the model? What is the, you know, I'd like to see you take someone through this process. And that's another thesis unto itself, like really deep, right? I couldn't help thinking about IKEA, of course, as you were talking. And, you know, if you ever put together any IKEA furniture, you know, the participation is the most frustrating part of it, right? So how do you know, you got to make sure, and like you say, when it comes to codes and liabilities and life safety and all that good stuff, there is a role for the architect. That's the other question I was having, is you sort of touched on it quickly, is where the facilitators, you know, do you just watch them put their stuff together and you know, you're going to be cringing every time they move a wall, but they say, hey, I really want my wall to be that short over here, and I want this wall to be really tall. And you know, as an architect, it's going to be the worst space ever. Like, how do you, you know, so these are fun things to think about, but the role of the architect's a big one in this, you know, and I don't want to take up all the time, but I do want to go back to that one issue of what's the right module to be thinking about in terms of, because I know, for example, that structure that you built could have easily been built with a bunch of sticks on the back of a trailer with a bunch of nails on site with a handsaw. You know what I mean? So and if you do have the skin on it and the installation and all that stuff, and that's all done off site, it makes a little more sense. And that's the key, is you got to kind of find that clutch point of what makes sense of getting stuff to the site. How much do you build? When do you tape it on site to make sure the weather's not there? And you're into it. I know your head is in all this, and it seems like you grappled onto a huge subject, because there's a bit of a reality to it. And you're there by yourself doing this, you know. This usually takes a team. Like, you know, you go get someone like Element 5 to help you out with this stuff, right? A manufacturing plant would help you out with this. And then a computer programmer would help you out with this. But you're all by yourself doing this. So I get it. Good stuff.
I have another comment. Just on the one hand, I really like what you talked about with the dwellers participating in the process. I think it does really create meaning and attachment to the built environment, and the environment becomes a really important part of you when you are participating in that whole process. You know, and I don't know if you're familiar with Nigel Coates. I think it was him who created this concrete apartment, and it was like stacked boxes. And that's all it was a shell, and each individual apartment owner or renter would create their own facade within that box. It was interesting when you put it all together and see the different things, but or the different designs. But on the other hand, was it deliberate to? What I'm hearing and understanding is that you've eliminated essentially the architect from this process. Was that the intent, or am I misunderstanding that?
No, it's definitely not the intent, and I'm not.
Okay.
I don't think I don't think I get this comment a lot because I think it, especially from architects, it seems like I'm putting us out of work. But I don't know. I see it as more of like I think facilitator is a good word because you're always. I think it's always helpful to have someone to reference, as you go through the process. And it's also a big part of it is also establishing this process, which would become an important role of for an architect. But I think a lot of it is just like I have this experience a lot with work, is that a lot of people think that design and good design is easy and sort of intuitive. So I imagine a lot of the kind of value of an architect would actually be enhanced here, because you're seeing that, you can design it with a 4-foot wall or something ridiculous, but it just wouldn't really make sense. And I think that's a lot of the expertise of an architect. Like, you can build a house any number of terrible ways, but if you hire an architect to do it, then I'm sort of, you're sort of getting a higher quality and you're getting higher expertise. And I think the idea of that is taking that expertise, and instead of embedding it in kind of a one-to-one client architect model, you're embedding it within the system and then allowing people to use the system and sort of distribute that expertise across more people. That's sort of like the aim. That's the goal.
Just to add on there, I think, like I said, we tried this before. We had a crack at it. The reality is 95% of homes still don't have an architect involved, right? So you could be arguing, if someone asks you again, say, no, I'm trying to bridge the gap to like compete with, I call them the 101 home plans, that you're actually going to compete out there and actually give a service that, basically tries to get better design involved. And I think that'd be an amazing thesis in itself. It's like, how do you compete against those developers and the 101 home plans or the Beaver homes or whatever they are that's out there that's just making bad houses, right? So I think that's good. But again, that's another thesis, so the where you jump in there is so intriguing to me. So that's not but the role of the architect, yeah, I can see it. It's a new role. It's a role that we haven't done before. How do you give a service to the general populace in designing and dwelling for their own particular home? Like, a lot of people will hire a developer that don't have the architectural kind of background, or they'll hire a builder who says they're designers that don't really, So then you got to really kind of define what your role is really, which is an interesting one in that participation. And what is your value? What's your value? So it's hard. It's hard. As architects, you're always, every day, you're trying to describe your value. It's because there's so many intangibles that people don't believe in. They understand the value of a structural engineer because the building has to stand up. So that little bridge right there, that little gap bridge, that'd be really interesting. So there's a social aspect to that. There's a participatory aspect to that. So you're onto something there, but that's a really tight point, if you know what I mean. Like, how do you define that? That'd be intriguing. That'd be fun. You just call up and you're the architect that's on staff that day, and you help them, guide them through the process of design. And when they make a wall that's too short, you say, you know what, that might be a little bit too short. And by the way, you need another exit there because the code's going to tell you that you need one. And how about doing this? Or do you what interface do you deal with the client? And maybe it's only an hour consultation, and they play the game and they design a house with you, and they pay your $495 for your service, and you move on to the next house. And then, I don't know, it's just intriguing. I'm like, what do you think of that? Confusing?
Yeah, it's definitely confusing, and it's something that I think I don't really have an answer for yet. And I feel like that's just going to be my career, is figuring that out.
Okay, good.
But I'm excited for that.
Let me know when you figure it out. I'll sign up for a consultation.
Yeah.
So at the end of your thesis, you had something constructed. What's the story there? You winter came along, or you didn't have enough time, or?
Well, you know, I hope to build a fully enclosed, insulated like structure, right?
Yeah.
Like fully test
Yeah.
the system, but it's just there was a number of things. The price of lumber has just gone crazy.
Yeah.
I just underestimated the labor, which is really ironic, I think.
Yeah.
But
Yeah.
you know, even as efficient as I tried to make the system, it's still a lot of work to move all of that lumber and cut it and put it together. So, and I was basically did it myself. So it would have been nice, you know, without COVID going on, to have a team of undergrads or something, like just to kind of be able to just produce more, because that's really the reality of it, is that it takes time to build things. Even if you're doing it prefab,
Sure.
it takes time
Sure.
and labor. So it's I still think it was really great to test though at full scale, especially when you're dealing with kind of moving components and how big are these things going to actually be, because everything on the computer just seems so small and light and there's no gravity. Where when you actually build it and have to move it across the property, I learned a ton just doing that.
Yeah. That's great. That's good stuff.
So we've got a few minutes left. I'm going to open it up to the rest of the committee as well, if there are any comments, or continuing the dialogue with our guests as well. I was just going to say, Talbot, this is potentially a Ghost Lab 2.0 in Toronto.
Oh yeah. Well, we did a very similar one, so I feel for you. I know how long it takes to do all this stuff, you know, like, and you underestimate it. You only get a third of it built where you thought you were gonna get the whole thing built, and you're like,
Yeah.
But that's good. That's how you learn. That's one way of learning.
And
I mean, maybe if I may jump in. I mean, many important things have been said, and I think also that the participation, yes, participation doesn't exclude collaboration, or so there can be still a lot of collaboration happening, and there are definitely different levels of participation that you tried to describe too, Michael, in your overall in your thesis. It's not just one level of participation. It's not, you don't have to necessarily take on the whole thing. And another thing is also in what would be also more interesting to dive into is how this growth process actually would work, and once you've actually inhabited something and you decide to have the building grow on site, how does that actually work? So that would be something really to focus on more. But so don't want to repeat what everything's been said, but I mean also what Tanya, what you said, this does hit on something about eliminating the architect's role, at least the traditional architect's role. And it's almost something what Aldo van Eyck described in the 60s when he said, our future role as architects are to eliminate our role as architects, at least in the sense of the traditional kind of the designer saying, this is what a house is like, and this is how to live in it. And so I guess he was going something against that. And even the examples you've shown, Michael, when you're talking about Elemental with their half houses, it's a very limited, also kind of prescribed kind of level of participation as well. And the idea was actually to move outside of that. You can still liberate yourself from any kind of concept that you have, but once you have a concept, you can liberate yourself from the concepts. So that's at least a good platform to start from. But just to just make some remarks, because what I do think is I'd like to acknowledge, and I think was a fascinating part of you know, supervising you over the last how many months? 10 months, 11 months, whatever, and that you did engage strongly into this to this concept of open form that has been more or less strongly neglected by Oscar Hansen, who is also part of the Team 10, which a lot of us don't realize. And these were long ago already mentioned kind of concepts of actually that architecture should not be a closed form, but be an open form that can develop. And then it moved into the participatory kind of level of architecture. Johannes Olivgren was one that you did not mention, is a very prominent figure in participatory design, and then moving it into the open source. So I think you really have you really nicely put that all under the umbrella and pulled those ideas together. also, and then bringing in, as Talbot said, another complexity of it, the ecology and the sustainability of where is this material sourced, how is it processed, does it come to site, and a lot of things that you weren't even able to mention today. Even the finish of those components is a pine tar finish, so a very ecological approach to what you're doing. So I found that it was a fascinating project. You know where my disappointment is that I would have liked to have seen it finished. So just as much as Talbot saw, but I must honestly say it was a really fascinating process. I enjoyed it a lot, and I am myself so disappointed that I couldn't, be up there on the site with you, as you said, with a group of undergraduate students with this kind of design build thing, and it would have been even better. But I'm already, under the circumstances and the conditions we have, very, very, very happy to what level you've reached here and what you've achieved. So thank you for that.
Do you want to add anything?
Me?
No.
Oh, Jason.
Sorry, sure. So thank you, Michael. I want to say that, yeah, throughout this whole process, it's been great to see the detailing evolve and the construction of that actual product. Same thing with Paul. It's, we wish it was a fully constructed thing, and I think under different circumstances, it would have been for sure. Based off of your past work, your undergraduate and graduate experiences, I have no doubt that this structure could easily be built by you alone. And just thank you for your presentation. I think everything is top notch, and congratulations.
Before we close out, and any last remarks from our guests before we ask Michael to step away?
Can I just,
of course, Marco, yeah,
add a couple of comments. One of the basic questions that came up for me, Michael, is who is this for? And I'm trying to imagine the client who would be wanting to go through this process. And the reason I ask that is that I think we operate in an environment where we operate primarily as consumers. And that's very true in the housing field, right? In the housing market. First of all, right now, of course, the idea that a house is an asset rather than a place to live. That's a big issue. But even more so in the context of what you're doing, this idea that we're a society that just kind of purchases product, and we buy our homes that way. And that's why you have the 101 home plans being so successful. And that's why 95% of housing doesn't involve architects, because it's basically this mass-produced product. So part of my question has to do with that. Like, how does one operate in this way in a society that has become very much a kind of product-oriented, consumer-oriented society, including in the purchase of housing? And also that comes with this mentality that, I'm the customer, you deliver me the product, it's got to be right, it's under warranty, all that stuff, and I can kind of wash my hands of it. I've paid the money, and I get my thing. So that was one question for me, and and it's not to take away from what you've done, but it does raise a question for me of how much of this is driven by demand and how much of it is maybe a bit of an architect's fetish. And the reason I asked that question is a question I always like to ask students when they're proposing projects similar to yours is, if this is such a good idea, why isn't it already happening? And I think those are always really interesting questions for you to ask yourself in terms of what are the obstacles to this, right? We might all think it's a great idea, but we also know that, so did people 50 years ago. And yet we're still talking about it in similar ways. Obviously, there's been some advances here and there, but it's still something that operates very much on the margins and very much in the context of schools, right? Like this is something that we seem to be endlessly fascinated with in school. So those are some of the questions that I think are worth taking away. It's like, yes, this is all, we can all buy into it at a certain level, but I think it's important to ask what are the obstacles to it. Another example for me is Avi Friedman and the Grow Home, which you reference in your document. Yeah, there's been a bit of uptake, but it's not like it's kind of revolutionized the housing industry. The persistent dominance of that industry is still the 101 plans model. So I think these become interesting questions, like what are the obstacles, and maybe there are structural and cultural issues that also need to be addressed at a whole other level than what you can possibly do in your thesis. But I think those become important questions in terms of setting a context for what you're doing.
Maybe that's a good place to kind of.
I'd like to thank him. That's really good work. I think as the more the comments are coming in, and the more I'm thinking about your work, is that a lot of this has been done, a lot has been tinkered with over the time. I think like there's so many people doing modular this and that, and they're coming up with panels, they're coming up with whole walls, they're coming up with, so there's a lot of people in the forefront technically doing this. The social aspect, which is really interesting, is that participation part. And trying to get people, and I think there is a little bit of a demand, because we have people coming in saying, listen, I think we need an architect. We looked at those home plans and there's something there we don't like, but we can't afford you. Can you help us out? So there is a little bit of a demand. There's some people who are looking for that. And I think the younger generations are a little more savvy in their, just like the food movement, they want to know where things are coming from. They want that participation. They want to be involved in that. So I think you're onto something there. I really do. And I think, thanks for that. And I think prying a little deeper into that is where there's a really interesting bunch of questions that are kind of unique. And thank you.
Yeah, I really appreciate, Michael, your passion and your energy. And it's the whole hour of listening to you and your project and understanding the background has been really engaging. So thank you for that. I just can't help but ask this question, or not a question, but just a comment. And it's a little bit off topic, but there's this test about how people do things. It's called the Colby, and there are 4 levels, and you're scored from 0 to 10 or 1 to 10. And the first one is fact finder, where people collect facts. Some people do it a lot and some others don't. There's no good or bad or right or wrong. And then there's follow through, where people actually have a list and they follow through. And then there's quick start, and a lot of entrepreneurs and architects tend to be quick start. So they need things right away. They like to plan things, etc. And then the last one is follow through, implementer. And that's someone who likes to get their hands on it and build it. And I'm curious to know, I want you to take this test. If you're a follow through. So we do this test for our employees to understand how they work and how we would relate to each other. And I'm just curious if you're a implementer, because you like to build with your hands, and maybe you're both a quick start and an implementer. But thank you.
That's maybe a nice way to end. I'd say, knowing Michael a little bit, I think he's potentially all 3, which is maybe
the detailing.
Maybe he'll need to continue this thesis for the rest of his career. And I think it's exciting to hear him say that this is a challenge that he's already decided to take on. So that's great. Michael, we're going to ask you to step aside, and your thesis supervisor Paul will contact you following the deliberation. Okay, thank you.
All right, thank you, everyone.
Thank you, Michael.
Do you want us to stay on, Carl?
Yes, please.
Okay.
We're going to give it 15 seconds. We'll hear when it's